Welcome to part 2, and in part 2 we're going to go over light and sound, two very important examples of waves. We'll start with light, or specifically the electromagnetic spectrum. Now what you're going to be doing in a project that I'll explain in a moment is you're going to be defining the properties of the electromagnetic spectrum. You're going to be listing the waves in some kind of order using the defining properties, and you are going to be outlining and thinking about the dangers associated with those waves. So what is the electromagnetic spectrum? Well, basically it's a bunch of waves with a lot in common, right? And what they've got in common is where they come from. Now, electromagnetic waves are given off by objects that have energy. Specifically, they have energy and they are at a temperature of above absolute zero. Now, this is something we will cover in topic 8. We don't need to go over it now. But basically, any object that has energy will radiate some kind of wave. And those waves that are radiated are called electromagnetic waves. The full group of waves that is radiated, right, is called the electromagnetic spectrum. And there's a whole bunch of them. There's radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma. Now, sometimes radio and microwave are bunched together as just radio, okay? Visible is sometimes split up into the individual colors. So apart from that, this is your full spectrum here. Now, what kind of waves are these? Because we've spoken about transverse and longitudinal. Electromagnetic waves are a little bit special. They are transverse because the oscillation is at 90 degrees to the wave direction, right? So if the wave is moving this way, if you can imagine a ray of light going this way, right, what we see is the oscillation here at 90 degrees. But what makes electromagnetic waves special are two things. One, that there are two types of perpendicular motion, not just one. And then secondly, what is it that's actually vibrating? Now, the defining feature of an electromagnetic wave is that it's made of two vibrations, not one. So it's not simply a wave moving this way and the particles moving up and down. What we've got are two things moving at 90 degrees to each other. Those two things, and this is it's the second point. It's not particles that are vibrating. Now, one of the most fundamental things about all of these waves is they do not involve particles at all. So you could ask, what exactly is vibrating? Well, that's the second point. What's vibrating is something new that I'm going to introduce to you. What's vibrating is a field, an area of force. So what you have are two fields, areas of force, which are varying in their intensity, and they're at 90 degrees to each other. What are the two force fields? The electric force field and the magnetic force field. Now these two vibrate at 90 degrees to each other, but also at 90 degrees to the direction of the wave travel, like that, perpendicular. Okay, now I'm going to go off on a bit of a tangent because this is one way of describing electromagnetic waves. In grade 12, we repackaged this entire section and we talk about photon theory. What if electromagnetic waves were not waves and they were actually photons? Now this is something I'll leave to you to maybe investigate if you're interested, or you can wait until grade 12 when everything will be revealed. So these crazy waves, which are actually the oscillating magnetic and electric fields at 90 degrees to each other, okay, what have they got in common? Well, they're all transverse, which is important. They all travel at the same speed. And that speed is very important. It's called the speed of light, and it's 3 times 10 to the 8 meters per second in a vacuum. Now that speed is on your data booklet. They all travel through a vacuum, and that's why it's so important to understand that there are no particles involved. Because if particles were necessary for this vibration to take place, then you would not have radiation traveling through empty space. So therefore, we wouldn't see anything coming from the sun, right? Light would not be able to travel in a vacuum because light is an electromagnetic wave. Because light is an oscillating field, which is not a particle, then we can actually receive the sun's energy. So that's another thing they have in common. They travel through a vacuum. And what's also important is that they can all behave exactly the same way. Now, these are ideas that we haven't come across yet, but they all reflect, refract, diffract, and polarize. These are the fundamental behaviors of electromagnetic waves. Okay, so these are important features that they all have in common, and they're the defining features of electromagnetic waves. So now we've outlined what makes them the same, what makes them similar, what makes them actually different. Now we can describe that difference using either wavelength or frequency. As you can see, and these are visual representations of what the different waves look like, they all have a different frequency and different wavelength. Now, considering that they have the same speed, by increasing the frequency, you are decreasing the wavelength. So whichever one that you use is valid and will affect the other one. So if you talk about the increasing frequency of the electromagnetic spectrum, that means you're looking this way, you're increasing the frequency. You can see that from the pictures, right? The frequency, the number of waves per second is increasing as you move this way. But accordingly, the wavelength is decreasing. So you can see how this wavelength, the distance from crest to crest, people can't see very well in that one, but there you can see the distance from crest to crest, distance from crest to crest, is decreasing accordingly, right? And this is mathematically justified by using the wave equation from last lesson, right? So what we're going to do is we're going to look at increasing frequency. As the waves increase in frequency, we go from radio to microwave to infrared to visible, ultraviolet, X-ray, and gamma. And in fact, there are new dangers associated with this increased frequency. And I'm going to leave that up to you to investigate. But by defining features, how do we describe these dangers in terms of defining features? What we're talking about is the wavelength or the frequency. Now, I want you to demonstrate your research and understanding by carrying out this task. This task is about an elderly lady living in your street who asks you what electromagnetic radiation is. She's very worried that it might be something that could hurt her grandchildren, particularly in mobile phone use. Find out as much information as you can so you can tell her what electromagnetic radiation is, what she needs to be worried about, and some of the uses of electromagnetic radiation so she can see why and how it's used. So basically reassuring her that electromagnetic radiation is safe, why it's safe, and then why it can be dangerous. Now, the mobile phone use is a dilemma because you might find that there is an argument either way. Now, I'm going to leave that up to you and your thinking skills, and especially your theory of knowledge skills, to try and come up with a good explanation or overview of the opinions. But I do need you to include in your content the nature of the electromagnetic spectrum, and I want you to consider, do a little bit of research in terms of the particle model. The different types of radiation, examples of where you find each type of radiation, examples of dangerous radiation, and more importantly, why they're dangerous. including that some kind of progression, right? So once you understand why they're dangerous, you should also be able to explain why one type of radiation is particularly dangerous compared to another, right? So there needs to be a relative aspect there. And then I want you to look into a discussion on the dangers of mobile phone use using different opinions from reputable sources, okay? Include the label diagrams that are cited and anything that's going to be useful. You can use any site, videos, as long as they're cited. And here are some keywords that you might want to use. It's not compulsory, but I do recommend that you get. So if you're not sure like what the minimum that you need to include is, I definitely include all of these. Did a rubric using the IB level descriptors, so it will look familiar. And more or less, it just shows you what I'm looking for. So I'll quickly overview level 7. So you can demonstrate comprehensive knowledge of factual information. You apply relevant information. So you definitely filter out the important stuff. Concepts and principles. You analyze the data, qualitative data thoroughly. So your explanation in terms of the dangers is, complete. And possibly, I'm trying to think of where you would have the opportunity, complex phenomena, then in the quantum part, there might be some nice explanations there that I'm looking for, because I haven't gone over it, so I'm really asking you to push the boat out there, and perhaps using the perpendicular fields explanation. But don't worry if you can't do that yet. Remember, this is where I need you to be in the end. But this should help you hone your skills. Your communication is logical, concise, and you're using the correct terminology. This is a tricky one because I can't. There's not a lot I can do to try and help you show insight or originality, apart from just advise you to take a risk, do things, try and do the work in a way that possibly I hadn't considered. And then theory of knowledge. This is new for me too, but this would be specifically relevant to the mobile phone use aspect. Okay, so what I'm looking for there is a strong evidence of personal exploration, consideration of different perspectives. I need to see evidence of both, and outline your argument. So how are you going to convince this little old lady that she shouldn't be asking her grandkids to give up their mobile phones? How do I want you to do this? Well, I'm pretty open to any idea. So you can video yourself explaining it, though you do need to take into consideration the different visual stuff that I need to see. So I do want some visual representation of the different kinds of waves, but you can draw them as you go. You can film yourself drawing and explaining. You can do what I'm using, which is a Screencast-O-Matic. It allows you to use the screencasting for 15 minutes for free. Prezi, Google Slides, infographic. There's some nice sites out there that allow you to make infographics for free. Posters, Flipbook, you do anything you want, really. Run by any ideas through me if you want. You can send me a suggested idea, but your outcome is pretty much up to you, whatever works for you. Okay, if you're not sure, you can just do it as a little as a document. Okay, but feel free to think about how best you present knowledge. All right, so there'll be a couple more assignments over Easter, and hopefully I'll see you all safe and sound when we get back.